Okay, this is the little section of P.4. Then we talk about rational and radical exponents and stuff. On your test, you are going to be asked to leave all answers with no negative exponents. If you have a rational exponent, which means a fraction, you can leave it. But you always have to simplify as much as you can. So if there's any way that you can simplify numbers, or if you have the same bases and you're adding or subtracting, whatever, you need to simplify as much as you can, okay? So let's look at a problem like 56. If I have 56, I have a big, pretty, whatever, parenthesis, however you want to say it, but there is a 3/2 on the outside. So what do I do with that 3/2 to everything inside that parenthesis? Distribute it, okay? Take a second and draw an arrow to each little thing so you guys see exactly what you have to do. And then rewrite it. This is 4 to the 3/2, right? Times A, and then this is 6/1 times 3/2, right? And then I have B to the 8th, which is 8/1, times 3/2. Does everybody understand where I got those numbers and all that good stuff? Okay, so let's simplify everything as we can. This little number 2 becomes the index, right? God bless you. So it's the square root. So what this is really saying, God bless you, is the square root of 4 cubed. Then what can I do with 6/1 times 3/2? When I multiply those together, what do I get? 18/2, which is? Nothing. So I have A to the 9th. You can also cross cancel here and get 3 times 3. Then I have 8/1 times 3/2. What does that become? 24/2, which is 12, because I can say 2 goes into 2 once, 2 goes into 8 4 times. So 4/3 is 12. Now I can simplify this a little more because, guys, what is the square root of 4? 2. So if I have 2 and it's cubed, what is 2 cubed? 8. So your final answer is 8. A to the 9th, B to the 12th. You need to always check and check and check and check. Can I simplify more? Anybody have any questions? Yes, sir.
What is it going to ask for when we have to do this?
It'll just say simplify the expression. Assume all variables are positive and do not leave negative exponents. There's 20 questions on your test. So again, 58 is the same sort of question. What do I do with that negative 1/3? I'm going to distribute it. Good. You could also put it in the denominator first if you wanted to. Hayden said I can. Yeah, that's fine. You can write 1 over u to the 4th, v to the 6th to the 1/3 if you want. Or you can distribute it and then do it. Doesn't matter. So I have u to the 4/1 times negative 1/3. And then I have v to the 6/1 times negative 1/3. Can I simplify anything with that 4/1 times negative 1/3?
Yeah, you can the negative exponent.
Right, but can I simplify the numbers? No, so this is just kidding. This is going to be u to the negative 4/3, v to the what?
6/1 times negative 1.
Well, it's 6 times 1, negative 6/3, which becomes what? Negative 2. Now, you guys are almost done here. You're close. But what's the one thing we have to do that Hayden pointed out from the very beginning?
Put at the bottom.
Got to put it at the bottom. All right. Okay, so when I put this on the bottom, like Carolina just told us, you can just leave it just like this. U to the 4/3, v squared. These problems aren't terribly difficult. You just have to take your time, because if you don't take your time, you could get a little confused at what you were doing where and all that stuff, and then, it gets a little hairy. So just be careful. Same thing on 60. This is still the same exact kind of problem. It's just a little bit longer. I have a 2 on the outside of the first parenthesis and a negative 1/3 outside of the other one. So just take your time. This 2 goes to everything on the inside. So it's 2, what? 2 to the 2nd power, good. And then x to the 3/1 times 2/1. and then y to the negative 1/4 over 2 over 1. If you guys don't want to write everything out, you don't have to. I'm just trying to show you what's the easiest thing I think to do. That's my first parenthesis. My second parenthesis, what do I do with that negative 1/3? Distribute it to everything. Good. So I have 8 to the negative 1/3, and then y to the negative 3 over 2 times negative 1 over 3. So now let's just go through. This is our second parenthesis. And let's just distribute. Let's just simplify. What is 2 squared? So I have 4. What happens here with 3 times 2?
X to the 6 over 1.
Right? Is it? Oh, this is 3 over 2? No, it's 3 times 2. Yeah. So it's x to the 6 over 1, or x to the 6. Good. And then what happens with y? Negative 1/4 times 2. Negative 1/2. Good. That's my first parenthesis. My second parenthesis, I have 8 to the negative 1/3. How can I rewrite that? Where should it go? Bottom. Can we already put the y on the bottom here if you want to? Yeah, let's just do that. Again, guys, you don't have to do everything in the same exact order I'm doing it. I'm just showing you, as soon as you see a negative, if you want to put it underneath, put it underneath. So this is 8 to the 1/3. Now what happens with y? Y to the negative 3/2 times negative 1/3. What happens with my 3's when I multiply those two together? The 3's cancel out. A negative times a negative is a? So I have y to the 1/2. All right, we can still simplify. There's still some things that we can cross out. Do you guys see something on the bottom and the top that is exactly the same? Y to the 1/2. So that crosses out, that crosses out. What's another way I can write 8 to the 1/3?
The third root of 8.
Cube root of 8. Very good. So this 3 becomes my index. So it's the cube root of 8, which is what number? 2. So now, is there anything I can cancel out between 4 and 2? Yep. 2 crosses out. This becomes 2. So I'm left with just what?
2x.
2x to the 6th.
Does the thing when you turn into a root on your record, it's the fraction we has a 1 aspect?
Like here, this one we had that. The index came out here, so we just found the square root of 4 and then cubed it, and then got 8.
You only do that if you can.
Yeah, if you can simplify. All right, I'm going to do 62 down here just so we have a little bit of room. We have 32 y to the negative 5th, z to the 10th, all raised to the 1/5, divided by, this is 62, 64 y to the 6th, z to the negative 12th, and that's raised to the negative 1/6. Okay, so first of all, what do I do with the fraction that's on the outside? 2. Everything. So I have 32 to the 1/5. Then I have y to the negative 5 over 1 times 1 over 5. And then I have z to the 10 over 1 times 1 over 5. Agreed? Now let's do the bottom. What do I do with the negative 1/6? To everything. So 64 to the negative 1/6. Y to the 6 over 1 times negative 1/6. And then z to the negative 12 over 1 times negative 1/6. Now if you want to leave the numbers for right now, that's fine. You can just leave them. If you want to simplify, if you already know what the 5th root of 32 is, okay, great. But let's just simplify where we can, where we see stuff. What happens when I have negative 5 over 1 times 1 over 5?
Negative 1.
I have negative 1. So this 32 to the 1/5, you can keep it or you can simplify it right now. We'll do it at the end. Y to the negative 1. And then what happens with z? Z squared. Because 10 times 1/5 is 2. Let me make that more of a 2. We'll leave 64 to the negative 1, 6. We'll come back to that in a second. But what happens when I have y to the 6 over 1 times negative 1 over 6? Y to the negative 1. And then what happens with my z's? Z to the second power. Now, if you wanted to simplify before, you could have done that. It would have been fine. The reason I didn't is because I just wanted to see if anything would cancel out. Do you guys see anything on the top and the bottom that's exactly the same? Z squared, good. The y to the negative 1, good. And then what do I do with that 64 to the negative 1/6? How do I rewrite that? How do I make a negative exponent become positive if it's in the denominator? Move it to the top. So this becomes 64 to the 1/6. So what this is saying, guys, is what is the fifth root of 32? And what's the sixth root of 64? What number times itself 5 times gives me 32? 2. What number times itself 6 times gives me 64? 2. So what's my answer here? That's it. I know it seems like a lot if you take your time and just keep reiterating what the rules are. If it's a negative exponent in the numerator, put it in the denominator. If it's a negative in the denominator, put it in the numerator. If you keep reminding yourself of that, it's not terribly awful, I promise. Let's look at 64. Can somebody read 64 to? Oh, never mind, I can see it. 64 is negative 8y to the 3/4 over y cubed z to the 6th to the negative 1/3. I would personally distribute first. So this negative 1/3 is going to go to the 8. It's going to go here. It's going to go here. And it's going to go here. It goes to everything since the entire problem is in parentheses. So I'm going to rewrite this as negative 8 to the negative 1/3. Y to the 3 over 4 times negative 1 over 3. I would write that out so you can see it. Then I have y to the 3 over 1 times negative 1/3. Z to the 6 over 1 times negative 1/3. Does anybody have any questions about what I just did? I literally just put negative 1/3 as the exponent to every single thing in that problem. Do y'all see that? Okay. So don't worry about the numbers right now. We can simplify that in a second. Just keep negative 8 to the negative 1/3. Then if I look at my y in the numerator, if I have 3 over 4 times negative 1 over 3, what happens to those 3's? They cancel, so I'm left with negative 1/4. Do you guys see that? Yes? No? Maybe? Okay, and then on the bottom, what happens to the 3 over 1 and the negative 1 over 3? That cancels, so I'm left with y to the negative 1. And then what about z? Negative 2, because 6 divided by negative 3 is negative 2. Okay? Now let's move stuff. So exponents are not negative. So negative 8 to the negative 1/3 should go where? To the bottom, so negative 8 to the 1/3. 8 still stays negative, just the exponent. Where does y to the negative 1/4 go? To the bottom, so y to the 1/4. Just flip it. Where does y to the negative 1st go? To the top. And then where does z to the negative 2nd go? To the top. Good. Okay, it's looking better. We're getting there. If I'm going to simplify this number now, what this is saying, this denominator becomes the index. It is the cube root of negative 8. What number times itself 3 times gives you negative 8? Negative 2. Good. And then what do you notice with the y's? They don't both have 1/4, but do I have a y on top and a y on the bottom? Yeah. What is the exponent on this y? 1, right? When you have it's okay. When you have the same bases and you're dividing, what do you do to the exponents? Subtract. So if I was going to say 1 minus 1/4, well, what is my common denominator between 1 and 4? 4. 4. So 1 over 1 becomes 4 over 4. Agreed? So what's 4 minus 1? 3/4. So this is actually y to the 3/4. You have to subtract. That's how we simplify that part. And then z squared just stays. Again, I know. You guys are sitting here looking at it like, what? You just have to take your time. You have to simplify as much as you can. I'll give you credit where I can, but you have to go through and simplify as much as you can. We're almost done. That was 64. Okay, let's do 66. 4y to the third, z to the 2/3 over x to the 1/2. Make sure I write this problem right, guys. Squared. And then we have x to the negative 3y to the 6th over 8z to the 4th, all raised to the 1/3. Okay, did I write that one right?
Yes.
Okay. So since I have an exponent on the outside, I'm going to distribute to every single thing inside, numerator and denominator. So this becomes 4 squared. Y, what happens when I multiply 3 times 2? 6. And then I have z to the 2/3 times 2 over 1. And on the bottom, I have x to the 1/2 times 2 over 1. Everybody agree with that? Yes? No? Okay. Thank you. Now I take my 1/3. I'm going to do the exact same thing when I distribute to everything, top and bottom. So I have x to the negative 3 over 1 times 1 over 3. Y to the 6 over 1 times 1 over 3. On the bottom, I have 8 to the 1/3, z to the 4 over 1 times 1/3. And then we're just going to clean it up. In this first parenthesis, what's 4 squared? 16. I have y to the 6th. And then what happens with 2/3 times 2 over 1?
It would be
4 over 3, perfect. And then on the bottom, if I have 1/2 times 2 over 1, I'm just left with what? Yeah, just 1x, good. Now on the other side, if I have negative 3 over 1 times 1 over 3, what is that?
Negative 3 over 1. The 3 over
3, which is?
1.
Yep, so negative 1. And then what happens with y? 2. On the bottom, what is this asking? We've seen 8 to the 1/3 in the last like 2 or 3 problems. What is 8 to the 1/3 asking? Cube root of 8, which is 2. Good. So you guys are going to start seeing that. That's good. And then I have z to the what? 4 over 3. Now, before you go do anything crazy, is there anything you want to move? X to the first, to the bottom? Okay, we can do that. I'm going to change that right here. Does everybody see what I just did? Okay, I'm just moving it. Why did I move it? Because it's negative. Good. Now, guys, we're multiplying. You can cross cancel here. You don't have to now combine all of it together. You can cross cancel here. Do you see any number on the top in either numerator that has a common factor with anything on the bottom? What? Okay, what about, let's do numbers first. Just a plain old constant. 16 and 2. Good. All right, 16 becomes what? 8. Agreed. What about, what else do you see, Christian? Tell me. Yep. You just said it. What do you see? Yeah, right? Z to the 4 over 3rd is in the numerator in one, and it's in the denominator of another. If it's the exact same thing on top and bottom, what can we do? Cancel it out. Perfect. Okay, so let's clean it up a little bit. We have an 8. I have y to the 6th and a y to the 2nd, which gives me y to the same base. What do we do with the exponents? It's not a power raised to a power. If we have same base, what do you do to the exponents? Add them. So it's y to the 8th over what? X squared. Guys, look at how this problem started out and look how it finished. Not beautiful, but it's not hard. If you take the time to actually write everything out, distribute everywhere, draw arrows, give yourself a picture, you will be okay. It's not horrible, I promise. Whoops. All right, let's go to these last few and then we're done. Get excited for this video later on. Woohoo! All right, 74. What kind of form is this written in? Is this rational form or is this radical form? It is radical form because it has a radical. So I'm going to rewrite this in rational form because we want rational exponents. So I can rewrite this as x to the what?
1/5.
Not 1/5. I agree with the 5th. 3/5. Where do we get 3 over 5?
The 3, the exponent, and then
The index becomes the denominator, right? Good job. So I have y to the what? 2/5. Good. Then over here I have x to the what? 4 over 10. And then I have y to the 16 over 10. Everybody good with that? Okay. So now I notice that I have two bases that are same. I have x's and I have y's. Can you simplify any of these fractions? What does 4/10 become? 2/5. And what does 16 over 10 become? Why did I do that? Okay, because you have to. But think about it. When you have the same bases, right, you can combine. When you have the same bases and you're multiplying, you add exponents. When we add and we have fractions, what do we want in our denominator if we're adding? I'm sorry. Thank you. Thank you, Joshy. But when we're adding and subtracting fractions, what do we want the denominators to be? The same. So look, I'm going to simplify my x's. I have 3/5 plus 2/5. That gives me what? 1. 5 over 5, which is 1. And then for y, I have 2/5 plus 8/5. That gives me 10 over 5, which is 2. Good. Very good. Same thing with 76. How can I rewrite this? How can I rewrite the numerator?
X.
I agree, x to the 2 over 3, but there's something that goes in front of that. A to the 1/3. Good. Oh, geez, we have the a to the 1/3 again. What's a to the 1/3? 2. We already know that. How can I rewrite the denominator? X to the 1/2. Perfect. So we just said, you guys just told me because we've seen this now 20 times, a to the 1/3 is 2. Well, do you guys notice you have the same denominator? Same variable in the numerator and denominator. We're dividing. So what do we do when we divide? We subtract. So I have to say 2/3 minus 1/2. Well, in order to subtract fractions, what do you have to have? Common denominator would be 6 between those two, right? Yes? So 3 times 2 on the bottom is 6, so 2 times 2 on top would be 4. And then 2 times 3 is 6, so on the top, 1 times 3. So I have 4, 6 minus 3, 6 gives me what? So this is x to the 1/6. Just simplifying a fraction. That's it. We have to remember our rules. If we're multiplying the bases that are the same, you add exponents. If you're dividing bases that are the same, we subtract. If you're raising a power to a power, what do we do? Power to a power, what do you do? Multiply. Good. All right, let's do this last one, then we're done. What is the little index in front of 78 on the radical that I don't see?
1.
Not 1. 2. So I can rewrite this as a to the 3 over 2, correct? B to the what? 1/2, 1 over 2. Good. What do I rewrite the bottom to be? A to the 3/4. Good. This is starting to sound better. And then B to the what? B to the 2/4, which is 1/2. Could you have written 2/4? Sure. What happens, guys, right away? What do you notice? You can be like, oh, this, I can cross that out. B's, right? You just go, boop, that's gone. So now we notice, okay, I have the same base, right? But I'm dividing. So what do I do to the exponents? Subtract, just like you see it. So it's 3 over 2 minus 3 over 4. Common denominator between 2 and 4?
4.
Okay, so this is 3/4. 4 times 2, 2 times 2 is 4, so 3 times 2. You guys agree? Okay, so 6 minus 3 is? Right, 3/4. So this becomes a to the 3/4. And that's it. You can keep all of your answers with fractions. That's fine. So what I suggest you guys do tonight is go back over the P1, P2, P3 test review video and then go over this one. All of that information is going to be on your test tomorrow. You have your quizzes. Everything that was on your quiz is fair game for your test tomorrow. There are 20 questions. So make sure I will have pencil sharpened, I promise.
2 over 3.